Thank you, Diana, for the presentation. I'm Professor Gustavo Miranda. I'm a professor of Federal University of Alagoas, and I'm here representing the Center of Excellence in Social Technologies, NIS, and I will present our work entitled A Computational Approach to Feature Selection and Enrollment Forecasting in Brazilian Schools. So, to understand our proposal, it's important to introduce important concepts. And the first thing is forecasting enrollment is a critical aspect of any educational institution annual planning because when the institution has the number of the students for the next year or 2 years, depending of the prediction, it's better to allocate people for the problem. It's better to plan the budget, and this action is more important specifically for developing countries, specifically the ones that have limited access to information. And the Brazil, it's a example of this type of country. And the Brazil has one challenge more than the others because Brazil is a very large country and has a comprehensive educational system, and this is so important to say because there is regions in Brazil that is hard to reach, and these regions does not have or do not have a adequate infrastructure. And this information is important because when the government is trying to deliver the books for these hard regions, it require organized, let me see, they need to organize better the deliver for for these books, and in order to avoid the financial costs. And to understand the structure of the education Brazil, Brazil has various levels of institution like early childhood, basic and secondary, professional and higher education. But it is important to note for this presentation or for our work, we only work with early childhood, basic, secondary, and professional, not higher education. And to understand the range and the breadth of the education in Brazil, here I point out some information. Brazil had 47 million of students across all levels of education. And for the childhood education, we have 41 million of enrollments every year. And for the elementary education, we have more than 26 million enrollments and more than 1,000 of schools. And for the initial years, we have approximately 10 million of students. And for the high school, we have more than 7 million enrollments, including the state network and the federal network too. And based on that, we have a specific question. May the data from the Brazilian government school census be used to predict the number of students for the next year? If so, which variables can be used in this process? It's important to note that the number of students for all of the schools in Brazil, it's a data from the Ministry of Education, but the census, it's a public data. So in this work, we are trying to create a correlation of this census with the private data of the Ministry of Education. And this census data has more than 2,000 of schools with 340 attributes for each one. And for all of the teaching stages. So for this work, we are trying to create a protocol to select the best features from the problem in order to create machine learning algorithms to predict the number of students for the next year. This prediction is so important because in Brazil we have the National Textbook Program. That's a program that deliver books for the students. So to have this number, it's important to say for the government the the amount of book that he needs to buy for the students. And our work has three main contributions. The first one is our experimental protocol, uh, that we are trying to predict the number of students for the public education, and we are going to improve the interpretation of the most important factors or the most important attributes that has that the most important attributes of the problem to predict the number of students. And for this, we propose and we evaluate different techniques of feature selection using Spearman correlation and the shape method. And the main objective of this work is to have a accurate prediction to try to reduce the government cost to provide the scholar books. And in order to understand the importance of our work, I'm going to present a overview of the enrollment predictions approach of the literature. So this area it's so large, so the works is very specific of a country and very specific of the institution, very specific about the type of the enrollment that they are researching. For example, there is work that's very specific for private schools. The other one is specific for public, and the enrollments. Some works wo- uh, uh, carries some works deals with full enrollments, the other ones with partial. So the purpose is very specific. And here in this table, I have some information to summarize what I was saying before. For example, here we have some works, and the objectives for these works is totally different. For example, the first work is signed for 2007. He is doing a forecast for the next year. The other one for the prediction only for the post graduation education. The other is trying to predict the teacher trends. So it's totally different. In the data set, it's very specific about the country and or of the region. But the method used is very common for the literature because they are trying to use MLP, random forest, SVR, only, let me see, basic algorithms of machine learning. And the metric is used to evaluate the forecasting. So this information is important because justify our proposal that is create a forecasting a system forecasting with a optimized prediction for the enrollment in the public schools in Brazil. And here we present some of our methodology, and I need to present the dataset that we are using. We use a dataset called MEC Prospecção that has more than 2,000 of schools and having 74 teaching stages and more than 1 million of records. And for each record, 40, we have 340 attributes. And we use this data set to predict only the next year or the number of students for the next year. So it's a huge data set. And here we have an example. In the first line, we have a school, and the second block we have the teaching stage of this school. Here we have some examples of elementary school or elementary teaching stage, And here we have a sample of the distribution of the teaching stage by schools in Brazil. For example, in the y x-axis we have the schools, and the y-axis we have the teaching stages. So when we have a green block, it means that this school has this teaching stage. But if we have a red block, it means that this school does not have this teaching stage. So this representation is a good way to understand the diversity of the teaching stage in the school in Brazil. And the data that we have is very different. For example, here we have the same school with two different teaching stages. In the attributes of the first one, we have uh, almost 70% of the data being binary, and the rest of the ones is, I think, is 30% is discrete. So the data from the teaching stage is different too. And how can create a protocol to select the best feature? So we propose using this feature some methods. For example, the first thing that we need to do is to collect the data, and after that we apply a correlation analysis using the Spearman correlation method, and we use a specific threshold to get only the best features. The best features that I mean is the features that has the more correlation with the target. The target is the number of students for the next year. And applying this method, we can reduce the dimensionality of the data set. And uh, if you are going to reduce it more, we can apply the shape method. The shape method is an algorithm that shows the most important features in the perspective of the machine learning algorithm. So it's a way to understand the best features for the problem and the best features for the algorithm. And I will show here one example applying this methodology in high school. So it's important to note that this methodology is applied in all of the schools to predict for the data for each one. So here in the left side, we have the correlation of these attributes in relation to the target. And in the right side, we have the most important features according to the shape method. So we can generate this graph for the SVM, for the random forest, for the MLP, etc. But the graph of the left side, it's a graph generated only using the data. And to understand what is the best features that we have in a problem, we are using the percent common element. That's a easy method to understand the number of elements of attributes that two different lists have in common. And we are using this method to understand the feature selected by each algorithm. For example, in the first column, we have here the Spearman method, or, or all of the attributes selected by the feature by the Spearman method. And for the other columns, we have the feature selected by shape method according random forest, MLP, SVR, and linear regression. And the number here is the similarity of the features that two different methods have. And here we can see in the green rectangle that Spearman method uh, have in general the best features according all of different perspective of the algorithms. Because of this, we are using this method to in our experiment. And if I try to understand what is the best features for this school according all of these algorithms and according to the Spearman correlation method. For this school, we have, for example, 5 features: the number of basic education enrollments with the years of 15 to 17, the number of elementary education enrollments for the final years, the number of basic education enrollments with color mixed and color white, and the number of elementary education enrollments for the initial years. So we can see here that different teaching stages can affect the prediction for the number of students. So put together all of these variables in a model can improve the prediction. And here I will present our experiments. We we realized, not realized, we did 2 experiments. The first one is to evaluate the most efficient feature selection method. So the focus of this experiment is to understand what is the best threshold that we can apply to the Spearman correlation method to obtain the best features, and to understand if if we apply the shape method, it's a efficient method too. And the second one is to evaluate the performance of the machine learning algorithms. We are using random forest, MLP, linear regression, and support vector regression. And we set up different experiments. The first one is training all of these algorithms using all of the variables, uh, training all of these 4 algorithms using the feature selected by the Spearman correlation method with the threshold 0.5, 0.6, and 0.65, and using only the best features according the shape method for the random forest, MLP, linear regression, SVR. So the 10 best, the 20 best features, and the third best features. And we are using the mean absolute error, mean squared error, root mean squared error, and mean absolute percentage error to evaluate the forecasting. And we are calculating the computational cost for this experiment too, and using the mean, maximum, and minimum number of features selected specifically for the Spearman correlation method. And I will present here some results of these experiments using only 10 records. So it's important to note that our data set is very huge, so it's hard to execute the algorithms in 1 million of records. Because of that, we are using a short number of records. It's for a future work to executing all of the records. And here I'm presenting the results of the feature selection method, and we can see here in the second column that the Spearman correlation method, specifically for the threshold 0.5, reached the best result for my MSE, MSE, and for the runtime. And to attest if these results are good, we are using the statistical test, specifically the Friedman test, to order the worst algorithm to the best ones. And we can see here that the algorithms that reach the best result was the ones that use the Spearman correlation method, specifically with the threshold for 0.6 and 0.65 for all of the metrics. And to attest if this result is statistically different, we are using the post-test of NIM and I. And for all of the metrics, the Spearman correlation method appeared to be the best one. And here for the runtime, we have the same, and it's important to note here that the shape method, it's a method that's a high computational cost, because he needs calculate each feature, the algorithm trained with all of the features and him removing each one to understand what is the best one between them. And because of that, the results for the shape method are not so good for the computational cost. And the correlation method about the Spearman, he has the best results here too. And here in this table, we can see the using the threshold to for 0.65, the feature selection method in mean reduce the number of attributes to 340 to 43 attributes with maximum of 184 and minimum of 2 features. So some schools needs only 2 features to predict the number of students for the next year. And here I will present the second experiment in order to understand what is the best algorithm. And for this case, we are ignoring the algorithms that performed poorly. For example, the Spearman correlation above 0.5 and 0.65, specifically because this the last one has the same result for 0.6. And we are ignoring too the shape method because it reached the worst results and has a high computational cost. And for this experiment, we are comparing only the algorithms using all of the attributes or not or. And in comparison with using only the attributes selected by the Spearman correlation using the threshold to 0.6. And in this table, we have the group of the results, and we can see that reducing the number of the attributes, we can improve the predictions according to my MSE, RMSE, and MRPE, and the runtime because we have less feature and the algorithms train faster. And the same with the table 6, we can reduce the number of attributes. And here, looking to this table, we can see that the algorithm that performed better was the random forest. And when we apply the the feature selection, the results can be improved. So this is very good because most of the time we think if we have a lot of data, probably the algorithm will perform it better because it will have a lot of information to use. But for this case, use only the best one or use using only the best features or the features with the best correlation reached or produced the best results for the machine learning algorithms. So in conclusion, we propose a feature selection method based on the Spearman correlation, and we compared it with the Shepard method, and we evaluate the efficiency of this methodology in the dataset make prospect sum that is very specific from the schools in Brazil. And answering our research question, we could see that the microdata from the Brazilian school census was sufficient to the enrollment prediction, and the Spearman correlation method with threshold 0.6 reached the best performance and reduce a lot of the variables. And we can see that reducing the number of attributes, we can interpret better the results. It's very useful, specifically for decision making. And this protocol can be used to predict or to use with any machine learning algorithm. So, finally, uh, one of the contributions that for our work is a protocol that can be implemented by the Brazilian government and can be and could be used by the education agencies like MEC and FNDA, and there is National Education Development Fund, and can use these results and this algorithm to predict the number of enrollments in order to support the decision making. And for the future work, we are going to carry some experiments in order to create a more robust result, specifically for all of the records of the MEC prospects on dataset that have more than 1 million of records. So it's a way to analyze or to validate our protocol. So it is.